Imagine a star moving so fast that it could travel from the Sun to Saturn in less than a day. A star so unbelievably quick that it breaks every rule we thought the universe had about speed, gravity, and survival. This is the story of the fastest star ever found, a cosmic bullet racing through the galaxy at speeds that seem impossible. And trust me, you'll want to watch until the very end, because the reason this star is moving so fast is stranger than anything you've ever imagined. Before we dive into the heart-pounding details, let's set the scene. Our galaxy, the Milky Way, is a massive rotating disk filled with hundreds of billions of stars. Most of them move in predictable orbits, drifting calmly through space at a few hundred kilometers per second. That's already fast by human standards, but in cosmic terms, it's pretty normal. Stars don't usually sprint, they glide, they orbit, they drift. But every once in a while, something extraordinary happens. A star gets kicked so hard, so violently, that it becomes a runaway. A hypervelocity star. A star that refuses to obey the galaxy's gravitational rules. The fastest of these stars ever discovered is known as S5HVs1. It's not a poetic name, but its story is pure science fiction come to life. This star is moving at an astonishing speed of about 6 million kilometers per hour. That's roughly 1,700 kilometers per second. To put that into perspective, if this star were traveling toward Earth, it would cross the distance from the Moon to our planet in less than 4 minutes. It is moving so fast that it is literally escaping the Milky Way. It will never return. It is on a one-way journey into intergalactic space. Now, before we go deeper, I want to ask you to stay with me until the end of this video. The explanation for how this star reached such insane speeds is one of the most dramatic cosmic events imaginable, and the final twist will blow your mind. Let's talk about how stars normally behave. Most stars are gravitationally bound to the galaxy. They orbit the galactic center in stable paths, influenced by the combined mass of billions of stars, clouds of gas, dark matter, and the supermassive black hole at the center. But sometimes, a star gets too close to something dangerous, something powerful, something capable of ripping apart solar systems and bending space itself. And that something is Sagittarius A, the supermassive black hole at the center of the Milky Way. Sagittarius A is about 4 million times the mass of the Sun. Its gravity is so intense that it can accelerate objects to unimaginable speeds. And that's exactly what happened to S5HVs1. This star was once part of a binary system, a pair of stars orbiting each other. They lived their lives peacefully until fate brought them too close to the black hole. When a binary star system approaches a supermassive black hole, something dramatic happens. The black hole's gravity tears the pair apart. One star gets captured, pulled into a tight orbit around the black hole. The other star gets flung outward like a slingshot, accelerated to hypervelocity. This is known as the Hills mechanism, named after astronomer Jack Hills, who predicted this phenomenon decades ago. And S5HVs1 is the most perfect example ever observed. It was launched from the galactic center like a cosmic bullet, shot outward with such force that it is now leaving the galaxy entirely. Imagine the gravitational equivalent of snapping a rubber band. One end gets pulled in, the other end flies away at incredible speed. That's what happened, but on a scale so massive that it defies human imagination. As S5HVs1 races through space, it carries with it the story of its violent past. It is a survivor of a gravitational encounter with one of the most dangerous objects in the universe, and its speed is so extreme that astronomers had to double-check their measurements multiple times. Nothing else we've ever found moves this fast while still being a normal star. It's not a neutron star. It's not a black hole fragment. It's not debris. It's a full-fledged star racing through the galaxy like a streak of light. Now, before we continue, this is the perfect moment to remind you to like this video, subscribe to the channel, and hit the notification bell if you're enjoying this journey through the cosmos. We're only halfway through, and the most unbelievable part of this story is still ahead. Let's talk about what it means for a star to escape the Milky Way. The galaxy's gravity normally keeps stars bound, even if they move fast, but S5HVs1 is moving faster than the escape velocity of the Milky Way. That means it will continue traveling outward forever, drifting into the vast emptiness between galaxies. Eventually, it will become a lonely wanderer, moving through intergalactic space where stars are incredibly rare. It will leave behind everything it once knew: the galactic center, the spiral arms, the star-forming regions, the nebulae, the clusters. It will become a cosmic orphan. But here's where things get even more fascinating. S5HVS1 is not the only hypervelocity star. Astronomers have found others, though none as fast. Some were ejected by supernova explosions, others were kicked out of star clusters. But the fastest ones, the true speed demons, almost always come from interactions with supermassive black holes. And that means the center of our galaxy is constantly shaping the fate of stars, flinging some outward while trapping others in tight orbits. Imagine standing near the galactic center, watching stars whip around the black hole at thousands of kilometers per second. Some of them get too close, some of them fall in, and some of them get launched outward like cosmic missiles. It's a chaotic, violent environment where gravity rules with absolute authority. Now imagine being on a planet orbiting S5HVS1 before it was ejected. You would have seen your star suddenly accelerate, the sky shifting as your entire solar system was thrown into motion. The gravitational forces would likely tear apart any planets, but the idea alone is staggering. A star system being flung across the galaxy like a stone skipping across water. As S5HVS1 travels, astronomers track its path backward. And when they do, they find something astonishing. Its trajectory points directly to the galactic center. It is a smoking gun. A perfect line connecting the star to Sagittarius A. This is the first time astronomers have been able to trace a hypervelocity star's origin with such precision. It's like finding a bullet and knowing exactly which gun fired it. But here's the twist that makes this story even more incredible. S5HVS1 is relatively young. It's not an ancient star. That means it didn't spend billions of years drifting through the galaxy. It was launched recently, cosmically speaking. About 5 million years ago, this star was peacefully orbiting its companion near the galactic center. Then, in a single moment, everything changed. The black hole tore the pair apart, captured one star, and hurled the other outward at unimaginable speed. 5 million years later, we detected it racing through space like a cosmic arrow. Think about that. 5 million years ago, early human ancestors were just beginning to walk upright. And at that same moment, far across the galaxy, a star was being launched on a journey that would eventually bring it into our telescopes. It's a reminder that the universe is constantly in motion, constantly changing, constantly surprising us. Now, as we approach the end of this video, I want to ask you something. What part of this story amazed you the most? Was it the speed of the star? The violent encounter with the black hole? The idea that a star can escape the galaxy entirely? Or the fact that this happened while early humans were just beginning to evolve? Let me know in the comments, because I love hearing what fascinates you most about the universe. And before we wrap up, if you enjoyed this deep dive into the fastest star ever discovered, make sure to like the video, subscribe to the channel, and turn on the notification bell so you don't miss any future explorations. Your support helps this channel grow and allows us to keep uncovering the most mind-bending mysteries of the cosmos. Thank you for watching all the way to the end. You've just learned how a star can be launched like a cosmic bullet, how black holes can tear apart star systems, and how S5HVS1 became the fastest star ever found.